My name's Peter Smurden. I'm the Secretary of the Melbourne section of the AES, and I'd also like to welcome all the members of the Australian Acoustic Society who are joining with us tonight for this, what we hope will be a very interesting talk on the renovations or reworking of Hamer Hall. Now, as it says up there, this particular presentation is going to be on the acoustic renovation of Hamer Hall by a couple of people from Marshall Day who are intimately involved in the exercise. Firstly, Peter Exton is going to talk to us, and Peter, looking at his CV, it looks like for the last 10 years he's been working with Marshall Day, but prior to that, he was intimately involved in music as a musician. Some of the items on his CV before 2003 are violinist of the Australian Piano Quartet, associate concert master for West Australian Symphony Orchestra, violinist including concert master in Orchestra Victoria, and then through to 2003 senior consultant at Marshall Day Acoustics. So this would appear to be a man who has brought knowledge and love of music to the design and implementation of performance spaces, which would seem to me to be a rather beautiful juxtaposition of talents and interests. And once Peter has given us the rundown on the acoustic design, then John Alenka is going to be talking to us about the electronic systems design. And John has had a wide range of experience with Marshall Day, and prior to that with a range of acoustics consultancies. And he's done work like building acoustics and sound system design for Amy Park in Melbourne, Warrnambool Entertainment Centre, Sydney Opera House stage management, system design and specification, Fair Work Australia court fit out with building acoustics. And so again, John has had a wide range of experience in systems within performance and public spaces. So first of all, I will welcome Pete to come and talk to us initially on the acoustic renovation of Hamer Hall. Thank you, Pete.
Thank you very much, and thank you for the opportunity to talk about this rather interesting project. As Peter alluded to, I had a rather split personality in earlier life. I did a degree in physics, but then found more opportunities professionally as a violinist, and I pursued that for about 25 years, both here in Australia and in Europe, before a chance meeting with Peter Fernside lent me to realise a way of bringing those two interests together. So I like to say it took about 25 years, but at last I brought the physics and the music together in my present work. The project that we're talking about tonight, the renovation of Hamer Hall, is very dear to me. I first played as a violinist in Hamer Hall in about 1987, and I spent a year with the Melbourne Symphony Orchestra in 1990, and subsequently came back to Melbourne in about 2001 and performed in there many times, as well as attending concerts there as an audience member. And I've worked closely with a lot of the musicians in the Melbourne Symphony Orchestra, the conductors, and also with Orchestra Victoria. So I've got really the interests of the musicians at heart. So my apologies if this is a rather biased, one-sided view, but that's the one I have, and hopefully John can provide a balance to that later on. The acoustic work in Hamer Hall was done as a partnership between Marshall Day and Kierkegaard Associates, based in Chicago. The room acoustics team had essentially three members from the Kierkegaard side: Larry Kierkegaard, Edward McHugh and Tim Gouldsrud, and there were 4 of us principally involved from Marshall Day, with input from other people from our office. The sound system design was mostly done in the offices of Marshall Day, and that team was led by John Lechner with Terry Ryan and Peter Jago. So this is the view of Hamer Hall that would have been very familiar to us all about 3 years ago. Essentially, it was very similar to how it was originally designed. We see the stage, we see the stage at one end of the room, the audience gathered around in a rather broad quasi-fan shape, quasi-shoebox arrangement. I'll talk about that again in a minute, facing the stage. The idea that it was very much designed as principally a classical music performance venue, principally for symphony orchestral work. When the hall first opened in about 1983, about 80% of the performances were classical music, with a minority of smaller scale amplified music, particularly jazz music and other amplified functions. In the course of the 30 years, the relative uses of the hall for classical music decreased, and currently it's around about 35% used for classical music, with the balance being amplified performances, not just jazz and popular music, but also schools functions, speech functions, conferences. In fact, it's a very, very versatile hall, and it was really that factor with the ageing machinery that meant that the renovation was now due. So what they were after was a much more flexible venue. The floor plans, or the seating plans, looked rather like this. The stage at one end of the room, if we're looking at the stalls level on the left-hand side, the hall opens to be quite wide at the stalls level. There's almost a fan shape in front of the stage with these splayed walls here and here. The width of the hall is about 35 metres, and the front of the stage is around about 20 metres, so that it's almost twice as wide as the front of the stage. When we move to the balcony level, the depth of the hall, front to back, is about the same as the stalls, but at the top level, the balcony seats, where almost half the seats in the hall are, the hall is quite a lot deeper. And we see in the section below here, we see that the height of the ceiling above the stage is about 22 metres, which is really quite high for similar concert halls. The rationale behind this design was to bring the audience as close as possible in terms of linear proximity to the stage, to try and give people the impression that they were part of the action that way. Variable acoustic banners were included in the hall. In fact, it wasn't just the banners against the upper walls that we see in this picture here. There they are. There were also operable curtains on the rear wall at the top, at the side, and in the centre section, and also at the stalls level and lower at the side walls here. The banners continued around the side of the stage, although they're not quite shown in this view. The effect of these banners, they were heavy wool fabric. They reduced the reverberation time from around about 2.2 seconds mid-frequencies to around about 1.7. So really they were quite effective given the volume of the hall. Our first job was to make an assessment of the acoustic and decide what we liked and what we didn't like, and this was done in 2 sections, a subjective stage and an objective stage. We started by listening to concerts, we listened to test signals, we listened to metronome signals moved around in the hall, and listened to the natural acoustic of the room as much as we could. We see one of the techniques that the Kierkegaard team brought to our attention, and we used quite effectively, was use of a parabolic reflector, and that isolates sound coming from particular directions, so we could isolate particular reflections off wall surfaces in the room and work out what they were doing in terms of delay, but also in terms of colour changes. We also had the benefit of relying on the impressions of musicians, because obviously it had been a hall that had been the workspace of musicians for over a generation, and a body of opinion had been set up both from the musicians but also from visiting conductors who were less familiar with this particular hall but were able to give a more direct opinion on it compared to other venues. We found that the hearing conditions on stage were quite patchy. There was a lack of impact in sound generated on stage by the time it reached the audience. It was like there was a veil between the audience and the musicians. In the stalls, the sound was very, very frontal. It was coming very much from the front. The fan-shaped walls of the display area were not contributing anything to the sense of envelopment for the audience. The circle sound was again frontal. Not much sound was getting very to the back of the circle because of, as I'll explain later on, it was being blocked by other architectural features in the room. The balcony seats were the most reverberant because they were exposed to the main volume of the hall to the greatest degree, and they were, for some people and some audience members, the favoured seats in the hall, but they were quite distant from the stage and felt that way because there wasn't a great sense of envelopment, despite the fact that the reverberant sound was coming from all around them. The sound was a little bit weak in the bass register. It wasn't really warm and full compared to the sound we've experienced in some other venues. And there was a complaint that at higher dynamics, especially the orchestral sound, the sound quality tended to become a bit harsh. We then moved to the objective assessment, and we set up our dodecahedral loudspeaker, which you can just see on the stage here. And we used the Dirac measuring system in addition to various other microphones to judge the spectral balance of the sound in the room. One of the things we were able to quantify was the distribution of EDT, or what we call early decay time. That represents the initial part of the decay from a fixed tone. In the stalls, it wasn't too bad. Right at the back, we saw a variation of between 2.2 seconds to 1.9 seconds deep under the overhang of the seats. I don't know whether you can make out the dotted red line here, which represents where the overhang is from the circle seats above. So at the back of the stalls underneath the circle, there was a reduction in the EDT, which led to a drier impression of the sound.
What time fraction do you use for EDT?
EDT represents the time for the first 10 dB drop in the impulse response, or the integrated impulse response. However, when we moved upstairs to the circle seats and the effect of the overhang became much more pronounced, we see a much bigger variation from 2.1 seconds at the front of the circle to 1.6 seconds at the most overhung seats at the rear. That meant that the sound quality, as perceived by the audience, was changing significantly. In the balcony, the variation was much less. The maximum value is slightly higher than in other areas of the hall because the seats are exposed to the full reverberance in the room. So the next stage was to try and work out how we were going to model any changes that we were going to make to the room. The strategy being we'd make some changes to the design, we'd put them in a computer model, and we'd predict the difference in the sound quality. So we built an Odeon model to try and mirror the existing conditions and to calibrate that before making any changes. The goals we set ourselves were to improve the hearing for the musicians on the stage as a primary goal, because the musicians are really the lifeblood of the performance in many ways, not just dear to my heart, but it's also their working environment. We want to make conditions as kind as possible for them. To improve communication between the stage and the audience, because if the musicians are feeling that their efforts are having impact, then they work harder and give a higher quality result, and they feel happier about it all. To improve the envelopment for the audience, to remove the frontal characteristics of the sound. To improve the clarity of the sound, so we could hear more detail in the orchestral texture, to take away this veil, this fuzz that's being added to the impact of the sound. To improve the bass response in the room, to give as much orchestral warmth from the deeper instruments, the double basses, the timpani, the bass drums, to give the full range of frequency response that we could achieve in the room. And to allow for greater operational efficiency in the hall, because this was a hall that was operating 70 to 75% some days as an amplified venue, not just as the treasured venue in Melbourne for the Melbourne Symphony Orchestra, the Australian Chamber Orchestra, the Concertgebouw Orchestra, which we're very excited to be hosting later on this year. The strategies was to try and increase the useful reflections for the musicians on stage, because what they hear is the direct sound plus any other early reflections integrated into that. We wanted to simplify the sound paths within the stage volume, and I'll explain a little bit more about that later. We wanted to improve the sound transmission between the stage and the audience, so that any subtlety in the sound on stage could be transmitted to the audience as easily as possible. We wanted to increase the lateral sound paths for the audience to generate more of a sense of aural envelopment. We wanted to remove as much low-frequency absorption as possible, especially close to the stage, because this has the effect of sucking out all the richness and the warmth of the low register close to the source of the orchestral sound. And we wanted to address the issue, if possible, of the harsher sound quality when the sound volume got louder, the upper dynamics. So we started by replacing the stage floor, which had been sanded to below its really safe limit. Well, it would have been if we'd left it for another 10 years and given it some more sandings. It was we built up a layer of double plywood with a hardwood layer on the top. Around the stage, this is a picture before the renovation, we see a lot of zigzag walls close to the stage. If I can get this, here we go, on the side and at the rear and on the other side. This hid the access doors for the stage, which we rebuilt and remodeled to improve access to the stage. But we also discovered that these sounds were actually these surfaces were scattering the sound and not providing a coherent set of reflecting surfaces for the benefit of the musicians. Just above the stage we had the choir seats and further box seats in niches behind the choir seats. The sound paths around here in this area of the stage enclosure were well and truly confused by all of these rather jagged surfaces that were breaking up the useful early reflections. Just above the stage we had a curved balcony front which wasn't serving any purpose architecturally and was actually pretty detrimental for the poor tuba player who had to sit just about here underneath it and was getting all of his sound being blasted straight back to him. Across the upper rear wall, of course, we had the organ, which was a rather weak-toned instrument, installed at the time in the belief that they didn't want to reproduce the wonderful big instrument that's installed in the town hall. As a result, the organ that was installed in Hamer Hall was never really strong enough for solid orchestral accompaniment, and it was placed about 6 metres too high in the wall. And the reason for that was initially the ABC had demanded a broadcast studio with visual access to the conductor at about this level here. The day the hall was open, they decided they'd relocate the ABC recording studio, and it's above the boxes over here. So the room was never used, but by that stage the organ had been installed. The poor organist was sitting about 9 metres above the stage. Not only did he have his back to the conductor, he was sitting behind this row of this selection of organ pipes here. So even if he turned around, he wouldn't have seen what was going on. It was not an ideal position to give an organ recital in this hall. You could have been in your own bedroom for all the effect that it would have had. The rest of the wall was occupied by these chevron-shaped surfaces. They were made of rather lightweight plasterboard, and again they were sucking low-frequency sound out of the room by dint of their lightweight structure, as were all the chevron-shaped surfaces around the stage. The stage walls were replaced, and the chevron-shaped plasterboard was taken out. Heavy blockwork was put in place. In the middle image here you can see a thick render which is placed over the blockwork, and on the right you can see in front of the render, which is the white surface, a thick ply surface and then a decorative surface layer. This was carefully constructed not only to be a very heavy weight, but also to avoid any air gaps in this structure which would remove low frequency sound. So this is the computer rendering of the stage conditions in the renewed format. We see new access doors in the flat walls around the stage. We see, instead of the zigzags, flat walls which then curve into the auditorium. And the idea is to funnel sound into the auditorium to encourage the lateral reflections off these curved side walls to reflect back into the stalls, to give the stalls-seeking patrons a lot more sense of envelopment. We covered over the box seats, which were very rarely sold anyway behind the choir, so we've got a simpler set of reflection paths around the stage. We've taken away the chevrons. On the rear wall at higher level is now a flat surface. It's actually a wire mesh and is pending the possible removal or possible replacement of the concert organ. over stage, we used to have a series of dishes, and they served to provide reflections for the musicians back onto the stage. As you can see, they don't cover the whole of the area of the overstage ceiling. They're about approximately halfway to the ceiling. They were about 12, 13 metres high above the stage floor out of the 22. They covered less than 50% of the area, and because they were slightly dish-shaped, whether or not a particular musician could hear his colleague from the other side of the stage was really a bit hit and miss. In the course of the history of the hall before the renovation started, several attempts were made to adjust these. I was actually present as an orchestral violinist during one of these sessions, and believe me, it really did make a difference. Before I couldn't hear the flutes, and after I sure could. However, 2 weeks later, it was back to one of the strange positions again from my point of view, because the lighting engineer had to put another rig up there. And the conflict between the function of the acoustic reflectors and the needs of the lighting designer caused a lot of angst in this setup. The decision was made to install an overstage technical zone with a variable lower surface, which in acoustic mode for orchestral music works as a large smooth reflector. And this is looking up from the stalls towards the surface of the reflector. You can see a series of panels which are operable, so they can be folded up and raised and lowered and adjusted. But they also cover a lot more of the area of the ceiling, much closer to 90%. So that as reflectors, they're much more efficient in reflecting sound back to the stage. This is a view from the front of the stalls showing the operation of the reflector. And one of the musicians from the MSO made this comment at the opening interviews with the conductor on national radio. And the idea of trying to improve the conditions for musicians certainly seems to have had a good effect. The overstage technical zone has the reflectors as their lower surfaces. On the right-hand side, we can see the reflectors in place, but the lighting bars lowered underneath the reflecting layer. This can be used for orchestral concerts with special effects where acoustic support is required on the stage, but lighting effects are also required. Musicians in that case generally use sconces or little lights on their music stands for their primary lighting source, but they can be lit with in a variety of ways for different effects. On the left-hand side, we see the reflector panels, or the wings, folded up. So each reflector panel has 3 segments. If I just go back briefly, in this panel here, for instance, you see there's a central strip which has the lights, and there's a downstage and an upstage panel. These panels can be folded up, and then they can be raised and lowered, and other equipment can be installed around them. And that's what we see on the left-hand side of the image here. We just see the central sections with the lights, with the other panels folded up. Moving from the stage area, we want to look at how the sound is moving from the stage into the hall. And we looked at the possible function of these splay walls where the room opens out very dramatically. We find that not only are the walls splayed in plan, but they're given this same zigzag treatment with the lightweight material. So we wanted to get rid of that. We wanted, instead of the reflections being scattered around, we wanted to use them in a functional way to try and steer the early reflected sound towards the audience in a much more meaningful fashion. Not only did we have the zigzags on the walls, we had the zigzags on the balcony fronts, which really weren't doing very much to assist the sound travel in the room. In fact, there was a potential trap of sound in this area here, and we've got these 3 rather medieval-looking shields which were installed as a post-commissioning effect to try to prevent sound being trapped in this corner of the balcony fronts here. Our solution was to try to make the join between the stage and the room simpler and much more functional. This is a vertical view of the rendered model, and we see the stage area. We see the stage shortened somewhat, so this is the lowered orchestral pit seats here, which are the stage is generally extended into that area for orchestral concerts. But we really see the curved walls at the front of the stage linking the stage volume to the auditorium volume in a much more functional way. It gives the possibility of reflections of sound reaching this part of the walls and being spread into not just the stalls area, but also the circle area, which has been rather neglected in the previous design. In the upper level, there wasn't so much problem getting early sound into the balcony seats, and so we didn't extend this curved structure into the balcony, but we did take off the lightweight chevron covering. The stalls are actually now narrower by 6 metres than they were originally. The computer modelling showed that it was very difficult to get a good envelopment of the sound at the far limits of the seating in the stalls area. And besides, there weren't really any seats there anyway because they put aisles there. So by taking 3 metres off the width of the hall on each side, we really lost a minimum of seating, and we were able to reclaim all of the aisles that were necessary under code by just rearranging the normal seating area with the same 2 aisles. This shows a picture of the heavily rendered walls at the side with small vents, with these vents for air conditioning and services systems. This was a view from the rear of the circle where the early decay time was so short. And to get sound from the hall, from the body of the hall into these seats, is rather like posting a letter through a letterbox. You've got a very, very narrow window from which to get sound in. Particularly, we can get some sound, direct sound, but particularly from the sides. And so not only was the EDT very short, EDT was measured with an omnidirectional microphone, but the sense of envelopment or the sense of sound coming from the sides of the hall was very, very limited indeed, because in order to get there, the sound had to somehow reach these wall surfaces on the sides of the circle area. But they were being heavily blocked by these overhangs, which were caused by the sides of the upper balcony coming down. So this was another view from the stage, and we can see this is the upper balcony sides coming down, and this is the blocked, covered over circle seats. Our solution to this one was to chop off 4 rows of seats from the side balcony arms. And on the right we can see that. This is the original position of the circle seats, and this is 4 rows back from where the side balcony arms were. So the other rows of seats were here, 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 and here, joining to the choir seats. So by removing that, we expose this part of the room as being useful reflection surfaces for getting more lateral sound into the circle. The upper wall surfaces above the balcony were featured these rather solid crystalline prism-like elements. We decided that this was actually causing us some of the harshness of sound because of the dimensions of the blocks. The smaller facets are approximately 600 millimeters wide, say this one here, and where they're pointing down towards the audience, there is the possibility of rising sound from the stage, striking these and being reflected back to the audience. Unfortunately, because of the dimension of this, it was preferentially reflecting at the very high frequencies. And we tried to test that and we built a mock-up and put it in a lab. And this requires a little bit of explanation. This was the this was a signal picked up by a directional microphone facing the mock-up of this facet as we moved it in relation to a fixed pink noise source. So this is the sound being reflected in different directions from this facet. And what we see when we're in the normal field, not the specular field, from this surface, we get a cut-off in the reflected frequencies at about this level of about 14,000 hertz. And as we move into the zone where we're in the specular reflection, we suddenly get a big increase in the high frequency content of this. And as we move beyond it, then we're getting lower. Now what we did here was reverse the direction of travel, and that's why you get a secondary peak, which exactly mirrors the first peak. And this was quite audible as you're walking past. It's going as you're just walking past this. So this led us to accept the the assumption that we were looking at very specialised reflections, very selective reflections from these surfaces. We ended up treating them with a very, very thin layer, about 3 mm thick layer of cellulose spray, and then they were recoloured to match the original scenic paint. We weren't allowed to do any other sorts of treatment because it was decided that they were heritage listed and part of the character of the hall. So despite the fact that in, well, European terms, 30 years doesn't sound like a very significant age, this is very much a cherished part of Melbourne's architectural heritage, and this was something that we would really advise not to touch. We found the original scenic painter, by the way, or we didn't, but the team did, and so we've got exactly the same colours on those surfaces. This is a picture of the Australian Chamber Orchestra rehearsing Beethoven's Ninth Symphony, a rather smaller orchestra and rather smaller choir than you're perhaps used to with the larger performances from the MSO, but it shows the functionality of the curved surfaces of the side of the stage and also the operation of the overstage reflector. This was taken, this photo was taken from halfway back in the balcony. The effect on the reverberation time of this change has been to slightly reduce the reverberation time in the hall from mid-frequency 2.2 to approximately 2.0. This was probably due, well, this is due to the fact that the technical zone blocks some of the volume of the room from the reverberant field, and also due to the fact that the seats were also changed and they're slightly thicker seats, so that the absorption coefficient of the seating has been slightly improved. This hasn't been detrimental to the multifunction use of the hall in any way. More significantly, though, the C80 or clarity that we use as a guide has changed in the stalls, where we've got a lot more benefit from the early reflections coming particularly from the side walls, which not only give us the sense of envelopment but the sense of clarity and the sense of hearing the detail in the orchestral sound. In the circle, the clarity itself hasn't increased so much, but the sense of envelopment has, because we're getting more of the sound from the sides. But in the balcony, we've got an increase in clarity, the blue line, particularly at the lower frequencies. And this is because the lowest frequency energy from the stage is being fed partly by the curved fronts of the stage side walls, but also because there's more of it that's reaching the reverberant field. Yeah.
Could you perhaps go over what C80 is and how it's measured?
Thank you for that. Yes, yeah, sure. C80 is a way in which we measure the proportion of energy that arrives before 80 milliseconds to the proportion of energy of the same impulse that arrives after 80 milliseconds. So if we get exactly the same amount of energy from an impulse response before 80 milliseconds and after 80 milliseconds, we get a value of C80 0. Now, C80 is important because in music it has been experimentally found that any reflections or parts of the energy of the spectrum that arrive before that time get mixed together and blended in, and the ear can't distinguish them as separate events. Whereas afterwards, the ear distinguishes it either as a late reflection or as part of the reverberant field, the sort of the ringing on. So we, in effect, any part of the impulse that arrives before 80 milliseconds increases our perception of clarity or detail in the music, and that's why we use C80. The effect, as noted at the opening concert, was that there was a lot more clarity subjectively felt in the hall. Ian Kelly has been going to concerts in the Hamer Hall for many, many years, but the freshness of the sound and the amount of detail that we heard in the Mahler's Third Symphony at the opening concert really was quite special, and the sense of feeling closer to the music was achieved by the envelopment caused by these lateral reflections from the side walls. Daniel Sumaji sang a part of the ring cycle as the bass baritone singer, also in the opening series of concerts, and was very impressed by the sensitivity of the hall. This was another thing that we found with the Australian Chamber Orchestra and their very small group that we found in the test session of only 14 musicians, and they could still play as softly as they wanted to and still be heard at the back of the hall. And that's partly due to the beneficial use of the early reflections in the room, but also the fact that we've lowered the noise floor of the room from NR22 to about NR16. That was the extent of some of the scaffolding work that was over the stage of the hall. In order to build the technical zone, the whole room was, well, the front half of the room was completely scaffolded so that they could get all of the joists and steel girders that support the reflectors over the stage. It was the opening concert, and that's back to where we were for John's part of the presentation.
Peter, sorry, could I just ask a couple of questions?
Please, yeah.
Firstly, how did they get it so wrong 30 years ago? Because presumably there were professionals involved in the time. And secondly, which do you consider to be the best seat in the house?
Okay, thinking of room acoustics and what are the significant factors has changed quite a lot in the last 30 years, 35 years. The principal difference is that we now appreciate that to feel enveloped by sound, part of the sound must come from the sides of the room. 30 years ago and 40 years ago, when this hall was designed, it was actually designed in the mid-70s. It just takes a long time to build these sorts of projects. But one of the important factors was known as the initial time delay gap. And that was the time difference between the arrival of the direct sound and the first reflection. And what wasn't understood is that the direction of those early reflections was so significant. So when this hall was first built, it was built with the dishes, those acrylic dishes, over the stage. And it wasn't just for the benefit of the musicians, but it was also designed to generate reflections from the stage back into the audience. And it was hoped that the initial very small number of reflectors and the weird shape that they were in, and the dish and the curved nature of them would be sufficient. It wasn't. As to the best seat in the house, every hall is going to vary slightly in terms of what you're after. If you really like to be immersed in the full thickness of sound without hearing all the detail, I'd go to the balcony. Although the richness of the balcony is now improved, and you'll hear even more richness of the sound. If you really want to hear orchestral detail and more orchestral clarity, I'd go perhaps into the middle of the stalls, or even the rear of the stalls, because the effector of the overhead reflector is going to give you a slightly more frontal sound than in the balcony, but it will be more direct and hear more detail, especially the instruments in the middle of the stage, which you can't necessarily see so clearly. I'll take more questions at the end of it.
Thanks, Peter. All right, some of you, I don't know many of you because I've been here for 10 years in Melbourne, but I'm not a member of the AS or the AAS, sorry, I should be, I used to be. So I worked on the sound system part of this. I'm not sure why the sound system and acoustics packages are lumped in together. It just seems to be the way it's been done traditionally in Victoria and in some other states. In some ways, you'd think it should be a separate package or part of the theatre consultancy package, because there is some acoustics involved, but it's really about technical systems. In the last few years, I've been working on for the theatre consulting side of the business called Marshall Day Entertech, where we tend to do a lot of the work that some others on this project have done as well. So it's kind of an interesting crossover. But there we are, we got the job, which is great. Beat some competitors, which we're really happy about. As other consultants might know, it's really good to get a job of this magnitude. That's a kind of screenshot. That's just a photo of the opening concert that Peter had a photo of before, which I just pinched out of a trade journal because I like the photo, and it was a corny heading. So I just thought I'd start. There's no doubt consultants here. Hello, Mark. This job is kind of like a theatre, really, in many ways. The only thing that's missing from the theatre aspect is a fly tower and a proscenium. In all other aspects, it's pretty much got all the technology, staging, lighting, AV, sound that a theatre has that we do quite a bit of work on. And it's just interesting to see this matrix that I just found today, actually showing all the different elements of that, just that theatre part of it. So we weren't the only ones. We were this part here. That's Marshall Day, but there are also others involved. Hanson and Associates, who are our friendly competitors just around the corner here, and Shula Shook, who were the theatre planners, theatre consultants, I suppose you'd call them, and they were originally from Chicago, or they still are from Chicago. And then there's a whole lot of other stuff there as well. This is sort of a photo of the previous system. And it sort of, I think one of the briefs from the Art Centre was to, and sort of the architectural team, was to clean up the look of the place, including the, around here, which Peter mentioned, this tech zone, it just looks like a mess. When I went there, you just looked up and saw this unholy lot of truss and speakers. So that was one of the aims. The old system was a Mayer system, which for its time was pretty good. It's basically based around MSL4 active speaker clusters, which are kind of horn-loaded. They were one of the first kind of production active speakers, and they were pretty good for their time. And in the middle, I think the main problem with this system, talking to some of the older sound guys at the Art Centre, was the coverage in the stalls in the middle. It was very hard to make a point-and-shoot box cover the middle of the stalls very evenly, without having this big mass of speakers. And I think the other issue was when a tour came in that didn't want to use this system, they had to take the whole thing down, or get it out of the way, then hang the new system and put it down, and I think it was quite inefficient. So the sort of brief we had was to, and the Art Centre wanted something that most touring acts would want to use. And here's another shot of the old system. So basically, there were some stage edge speakers they put on the lip, and some CQ cabinets, which are just, I think, 15 and horn boxes, and that was it. And that's what they used to bring the image of the sound down to the stage. It's also worth noting, Peter was talking about the broadcast, ABC broadcast room that was up here, and it's still there. It's been renamed I think the audio broadcast room, where it's not just the ABC who will use it now, it's other users. So I think it's basically like a bare studio, and others can bring in mixing consoles and what have you. And part of the job is to reinstall tie lines up to that room. I'll cover that next. And the other part of it was the underfill systems for the circle and the stalls. I don't know, sorry. Which are there. These are basically UPM Mayer speakers that were. Basically the new design followed this design, except that we used more of them. There were only 8, I think, on each level, and I think the new design has 12 or 13 on each level, just to provide better coverage. So here's a bit of sorry, I've got a stomach cold. Here's a schematic of the old system. You can see how unwieldy the left, centre and right clusters actually look, and also there were 3 delay speaker hangs at the back, and some sub-bass cabinets down here, either side of the stage at stage level, in hidden recesses either side of the stage. The signal processing was basically done by a SoundWeb unit, which is here, which is shown by that block there, and the rest of it was pretty much just passive patching. And they also had like a rack full of active splitters that they used for fallback splits or recording. I started working on this project in late December 2010, when someone else in the company moved on. So some of these slides is work that I didn't do, but I mean, we just carried through as one company anyway. It's interesting, we worked very closely with the Art Centre because they had pretty clear ideas what they wanted, and fair enough, because as consultants, we just sort of walk away from it after a year or so, and they're stuck with it for another 10 or 15 years, which is roughly how long the last system was installed for. So they took it on themselves to run a kind of loudspeaker shootout, and they had, at the time, they had 5 manufacturers willing to do it, and so they did basically single line array hang, and had listened to it for each manufacturer, and then they had these on-stage stacks, which I don't think particularly work well when you look at it, and there's reasons for that. And the old left sort of cluster is there and there for reference. So they had 5 manufacturers. There was one from France, well-known manufacturer that wasn't there, and from that they kind of worked out which systems suited the hall. I don't know, I'm not such a fan of doing this sometimes, because often you can't have all the systems in the room at the same time, and when they are, they're in different locations, so the room has a different response. But they did scoring sheets to sort of try and keep it a bit consistent. I've got that there, which I'm not going to show you today. You can ask me later if you like. So here's so what our role in the job sort of followed what we did at the Sydney Opera House Concert Hall, where we came up with a concept design and then invited different vendors or speaker manufacturers to come up with the design as part of a tender. But you can't just say, go away and design it. You have to come up with some sort of concept. So this is the concept actually Peter Holmes, my predecessor, came up with, which is pretty much what got installed, except for the centre cluster was reduced to 2, just reduced to 1 line array, and the delay loudspeaker arrays are increased from 3 to 4, but pretty much the concept is still the same as that. And there's a kind of SketchUp drawing of what the old design looked like, and that last design, the concept changing there. So you can see, even from this, it was a lot cleaner looking, neater, easier to get out of the way. There, see, if only it was that easy to install. So I'll jump to what the whole system was. I think this is cursed. The contract value is over $2 million. That's one of the largest sort of sound system projects I've worked on. That just wasn't the black boxes. That was the cabling, infrastructure, fit off, installation, builder's margin, etc., etc. So there was actually quite a lot that had to come out of that budget. You can read all those statistics there. The interesting thing, I think, was that there are a lot of loudspeakers involved, 168, which I totalled up today.
Can I just query the inputs and outputs?
Yep. There's around 100 outputs to drive 168 speakers. Some of them are doubled up. Yeah.
So when you say 12 system inputs?
It's a Digico mixing system, and they have the option to, well, there's probably more than 12, but there's 12 available in the system. So it basically, the system drive is AES into a Mayer box. And also we replaced the active microphone splitters with just passive transformer splitters. So because it was so large, we had to break up this contract. It was going to be too difficult to manage as one package, so we broke it up into 3 packages. There's package A, which was basically all the permanently installed speakers that are hidden, that don't move, like the stage front speakers, the under balcony speakers, anything that was hidden. And then there was the glamour package, which was package B, which everybody wanted to get, which was basically the touring system for big line arrays. And then package C, which was the one that really was important, was the infrastructure integration, so that's the fit off of all the cabling, so that we had MADI going via coax, Ethernet, just normal balanced audio, which we also specified all the cable is AES compatible. There's optical. I think there was one other, which I can't remember off the top of my head. So the normal way we do this in theatres is to get the electrical contractor to run all the cable because it's cheaper than having an AV or specialist contractor do. Then it's fitted off. Interestingly, in this case, the company fitting it off was an electrical contractor. Others involved were Jan's, who did all the staging, and then there was HME, who was sort of Jan's competitor. They worked on a sort of very complicated moving door system either side of the stage to cover up speakers, which I'll cover a bit later. Don't have to read all this, but there was 4 operating modes. Going backwards, there was the full concert mode with all the line arrays out, high level sound. The next one was this, and also either side of the stage we had roll-on line arrays as well to replace the 2 sort of small boxes you saw on the other photo. Then there was a sort of standard amplified mode, which would probably be suitable for not rock gigs, but jazz or something like that, that used the line arrays but didn't have the on-stage speakers. There's light amplified, which would probably be okay for MSO Pops and Morning Melodies, which just used the centre cluster and some of the hidden speakers. And then there was the unamplified mode where there was an edict from above that someone in the MSO or the Art Centre wanted to have orchestral concerts with no speakers visible at all. So that was that mode, and that was actually one of the trickiest to achieve. So we did, our role in this was to do a specification and kind of pull the whole thing together. So that was, we did about 40 drawings, went out to tender. There's an example of technical panels on the sort of stage stalls level, sort of on the ground floor, I suppose you'd say. So there was quite a lot of detail. It was about 135 technical panels that we worked with the electrical consultant, Oricon, and the Art Centre, where they'd go and what would be there. So it wasn't just us sort of telling them what to do, it was kind of quite a collaborative approach. There's another kind of schematic showing all those technical panels of each cable type in one drawing, because I found it was quite difficult just looking at drawings, floor plans with technical panels and cable types on them. I had to get these done so we could just sort of get a global view of what was going on, because there were so many connections. And then we had 4 racks on the prompt side of stage, or on the left-hand side of stage, looking out to the audience. This was the first go at it, where we got all the Art Centre sound guys into our office and we printed up full-size racks, put them on the wall, and then cut out all those XLR connectors, all the Digico units, splitters and everything, and said, right, there you go, now how are we going to put this together? And this is what we came up with as the first pass, and then subsequent to that everything got changed around, but at least it was somewhere to start. The other thing to note is that although it was a Digico system, completely digital pretty much, the Art Centre wanted the option to have, say, some heavy metal band came in that wanted to use analogue everything, analogue foldback desks and analogue front of house, which you don't see much anymore. There was the option to bypass the Digico, and these big multi-pin connectors down here are directly linked to the transformer isolated outputs of the isolation, the passive isolation units we've got. So there was an awful lot of flexibility. This one down here goes to that ABC room. That was a 50-way, I think, from memory. So they could get an analogue feed up to that room, although it's probably not going to happen anymore. It's all digital. Some typical details of the panels. We drew all these with the big multi-pin connectors on the bottom left-hand corner. The other issue we had was the client couldn't decide which way they wanted to go in terms of the main speaker system. They previously had an active system, but there were some good options for conventionally powered, so having amplifiers in a separate room away from the main space. So that meant we had to document parallel cabling systems, which was quite irritating when we kept pushing them. Can't you just make a decision one way or the other? Then we could just get on with our lives. But that went on until basically the end of the the sort of tender documentation period. So that was kind of just a simple schematic of the left, right and centre speaker arrays, and then there was the conventional option. So we basically based the conventional option on DMB. It was one of the Art Centre's preferences, and the other one was Mayer active option. There's a summary of all the loudspeakers. You can sort of, I'm not going to go through all that, but you can read all this in trade journals, but it was actually quite a big job. The drive system was Dimitri system, which is a Mayer. It just wants to keep changing on me. So essentially, the analog I/O or analog inputs, outputs were up just a level below the stage level. This is some of them, and then the core of it, the matrix and routing units, are also here, up on level 1. The only reason they were up on level 1 away from the main stage level was because there was no room left in the rack, and also we were trying to minimise the amount of fan-cooled units down on the stage, because noise, the NR15 is very low noise level, so any noise side of stage when the doors are open would bleed through. And so basically on the stage level it was just input, output, analog and digital AES. The boxes would accept AES from the Digico system. And also down on B4 there was, we did have some conventional amplifiers to power the stage edge speakers, which were MM4s, which are just little cubes that don't have amplifiers in them. And the signals were, the signal was driven from those. We had 4, excuse me, I think in the end we had 4 tenders come in for this specification. I rang all of them, all the main players. Apologies to anyone I missed, but I rang all the main players to say this is out here in the public domain, put something in if you want to. So in the end we had 4. I think there was, it's no secret industry knowledge now, but there was Mayer, Martin, DMB, and Adamson, I think. And so in the end we had this bucket of money. There's sort of certain preferences for certain products, but all of those are great. All of them would have done the job. They just all sound different in the room a bit. And so all of them, interesting to note that people in the sound system field that use E's, none of the 4 proponents had E's models, they all had their own in-house systems. So I don't know what that tells you about E's. The Mayer one's fairly crude, you'd have to say it. All this shows is direct field, so this could just be outdoors. It doesn't actually sort of show the effect of the room. The room is just drawn there to show you where the direct field sound falls. It doesn't actually show you reflections or anything, but I suppose in this case it's good enough for what they were trying to prove. And we also had the benefit of the guys using systems in there before, so probably not the best way to do it, but it was good enough for this. So the one on the left is the main Mayer, the main left and right clusters. They could also move, I think this one here is forward, and it could also move 3 metres back to cover more of the seating area when the pit was up. And these are the stalls focus speakers, which will roll on speakers. I'll show you some photos of in a minute. Basically to bring the image down for rock gigs. See, Peter talked about these side walls being connected to the stage as part of the refit. Our issue was that we had to have invisible sound somehow, no speakers, especially when the MSO or another orchestra was on. So what we had to do, if you can see up here, this is a little line array in this, and this is a cutout here. This dotted box is a HB 700 sub, which is basically a 2x18 sub. But also you might just see here is a little column speaker, and I had some arguments with our acoustics people, sorry Peter, that they basically, this was a critical area for lateral reflections back into the stalls from the stage, and having a dirty big hole here wasn't going to help them much. So after much discussion and hand-wringing, the builder decided we did have to spend the money on coming up with a moving system. So essentially what it shows is this is a rear view here. Looking back, it's pretty hard to sort of take photos in here, it's so constrained. So there's a sub, a line array, then this column speaker, which is a cowl. So when there's orchestral pieces on, there's a door that moves up, this rectangular thing here, that moves up, and the speaker moves back. It's on a Serapid system, installed by HME and designed by them. The column speaker is a steered column speaker, which means you can angle the sound down or up and split the beam. Now, it's not the only one of its type. There's been quite a few of these around for years, and I suggested this initially, and I was held down by the sound guys. They said, "How dare you suggest such a thing going to our hall?" But in the end, luckily, Mayer came up with one as well, and it wasn't available until the death knell of this job opening, so it was actually, I think, one of the first systems installed in the Southern Hemisphere. And I heard it last year, and I thought, it does sound better than some of the others, so I was quite surprised, and the coverage is actually quite good. This sort of light blue area is an architect's sort of impression about how sound works from that column speaker, which may or may not be true. So that was a success in the end, I think.
It's worth it really, wasn't it?
Yeah. So these are the shop drawings from HME. They're quite complicated, and it was terribly difficult to install in such a tight area. I think the reason Jans didn't do it, the main staging contractor, was they were simply just too flat out with the main contract. Here's some photos of the tech zone that Peter was mentioning before. So this is basically Jans's realm. On this here we've got just off-the-shelf Cat 5 reelers. Jans also made big timber reelers for the power to supply the main arrays. This door here is one of the main array doors, so they can lift the main arrays up into this tech zone. There was a 3.5 metre restriction on the height. One of the tenderers came back with 3.7 or something and said, "Oh, we didn't realise you were actually serious about that dimension." He said, "Yes, we are. We just can't be any more than that." So they had to go away and redesign. And you can see the sort of top of the reflectors there. Part of our contract was to engage someone who was world renowned for aligning these systems. It was originally going to be Bruce Jackson, who was involved with Marshall Day on the Opera House Concert Hall system. Unfortunately, he died. So we then went to Bob McCarthy, who's wearing the funky blue glasses there, from Alignment and Design in the States. He actually aligned the original system, and Watchinell was on holidays at the time, but apparently he worked like a Trojan, did a really good job. The guy on the left is Nick Carroll, head of sound, who's still talking to me, so it's good. I think they're setting up a measurement mic for a stage edge speaker there. The difficulty was it was done over 3 nights, and they had 4 modes to align, so it was actually a lot of work. Bob uses a SIM system from Mayer. And there's some more photos during the alignment. You can see this is the right line array in the back position, and this one's in the forward. And here's the stage focus system. So it's actually 5, I think they're melody boxes, and a 2x18 sub. Behind that is another sub, so they were running a cardioid, in a sort of end-firing cardioid arrangement. Up here is one of the upper niches that we had some meaner elements to fire up into the balcony in the front of the circle to provide sound coverage when there was no arrays installed. This one wasn't installed properly. They took the easy option out and just installed the speakers flush with the the grill. They should have been turned around, and the reason for that is there was no concrete to support it on. They didn't put a support in, so that had to be rectified. And there's another view from the stage showing there's the second sub there. Yeah, and you can see 1, 2, 3, 4 delays, and there's the centre cluster. And I suppose all that's well and good, but I mean the main thing is that it works well with any act that comes through, and I think it has so far. And my favourite band, of course, is the purple one there, because I used to hire PA systems off him in Sydney, but they were pretty awful. But all in all, a really good job, and a few defects, and everyone worked really well together, despite the stress of trying to meet the time frames. And that's my thing.
Take questions if you've got any further ones.
I was at Hamer Hall when there was the Acoustical Society had a meeting with the brand engineers, and at that point in time they seemed pretty pleased with themselves. At what point in time did they become a little disillusioned with their design?
Look, I honestly can't speak for them. I don't know that they ever did become disillusioned. Fashions do change, and preferences of individual acoustic designers, acousticians, audiences do change. Part of that is generational, part of that is fashion, part of that is due to lots of factors. I honestly don't know whether or not the original designers did become disillusioned, but it is on public record that the client wasn't particularly impressed with the early result as soon as the Hamer Hall originally opened.
To what extent is the development of the C80 idea being helpful with more modern design?
C80 is very useful to designers of natural acoustics because it tells us something about how well the sound is defined by an audience, what the definition of the sound is, what the clarity of the sound is. It corresponds very well to the subjective impression of clarity of music, detail in music. So if you've got a large complex source like a symphony orchestra and you've got an oboe in the middle of it surrounded by a string section, you want to hear the character of the oboe, but you also want to get the atmosphere of the string section, and somehow you want to separate the two so you can follow each line if you so chose. And C80 is the parameter the measurable parameter, objective parameter, that most closely allows us to predict that ability in a hall.
How long ago did C80 develop?
That one I can't tell you, but I can tell you that it probably was earlier than lateral fraction, which was established by Mike Barron in around about 1975.
Yeah. I'm interested with the sound energy on stage, and obviously there's several components now that you've got strong lateral solid reflections coming back from the solid side walls, the straight side walls, and also now with the overhead reflector. I'm just wondering the balance between those two components, between the lateral and the overhead on stage, and how important that balance is. I understand the overheads can rise and fall.
That's correct.
What is the range of that movement?
Sure. The range of the reflections upwards is the height of the fixed structure of the technical zone, which is about 15 metres above the stage floor. And they will come all the way to stage floor. Not that we want to squash any musicians, but we do have that range. That has to happen just for maintenance reasons and also for when they were first installed. They were put on stage level and then attached to the winches and brought up that way. Generally, the smaller ensembles, when the Australian Chamber Orchestra travels to Melbourne with an orchestra of a dozen or 15 musicians, they want to create a more intimate quality of sound on the stage. So as we saw with the Beethoven Ninth Symphony, they physically make the stage smaller there's a rear stage lift which they raise to the top level as high as it can go. So the stage is already about 4 or 5 metres less deep. Then we lower the ceiling so that the impact of the reflections gives the musicians the impression that they're actually playing in a smaller space, so they can play a little bit more intimately and more delicately. Now, if the large orchestra were to play in a room with a very low ceiling, the sound levels on stage would be increased by the early reflections coming from the ceiling. So the trick there is to raise the ceiling to give the impression that the room is bigger, but also to angle the sound out into the audience so that the reflections above the stage form that arc. And that's calculated to push the sound into the audience space as well as to generate reflections on stage. And we use the full range. I think the maximum height we use is about 14 metres with the Melbourne Symphony Orchestra.
To what degree was virtual modelling used by yourselves, and was the client subjected to that? What was the response?
Virtual modelling as in the computer predictions?
As in replay, yes.
Oh, as in oralisation? Yes. We don't play that to the clients. The beauty of this design is that we were able to model in Odeon the existing conditions and calibrate that, and then look visually at the differences between the existing conditions and the predicted conditions for the different configurations. We don't, as a company, make a big effort to play oralisations to the clients. We tend to use it in-house, and particularly for locating late reflections and listening to individual impulse response to a clap. But when you get to the stage of oralising concert sounds, there are quite a few additional steps which lead to additional approximations being made. Things like the size of the source, the number of source positions, whether or not you coordinate them. Because if you're trying to reproduce a source as a symphony orchestra, you've got a source which is 18 metres wide and 10 metres deep. You need to have equivalent loudspeakers everywhere in the oralising program to reproduce all of that. It does get very complex. Those challenges can be met, but whether or not you can then say that you're accurate enough to be really useful, I don't know. I know there are companies that do that successfully, companies that market it. We've chosen not to use that as a marketing device, but we do use it as a research tool to listen to the individual impulse responses.
So it works for you with educated ears, but it's too complex, really, a process for the client to pick out, make sense of it.
I'm not going to say that it's of no use. I will say that we've chosen not to go down that path as a demonstration tool to clients because of the approximations that are involved.
Given the marketing of these processes,
yeah.
It's interesting to me anyway that the client actually insists on all of that impressive.
We were definitely not asked for that at any stage. No.
What systems were put in for the hard of hearing?
I think there's a loop, isn't there?
Mark?
I originally put in the infrared system in the first design.
Right.
Some time ago. That was a Sennheiser infrared system.
That didn't actually overlap either of our
No.
the briefs.
It could still be there.
That's probably in the fine print of the theatre systems contract somewhere.
So did you just use a loop, or did you put infrared in?
I didn't adjust it. I didn't put in anything.
Yeah, we didn't. It wasn't part of our scope, so we didn't involve it.
The old radio frequency transmission system would have been the same.
Okay.
All right.
Did you have to make changes to the air handling to achieve the noise floor?
Yes, we did.
What did you do?
Well, that was a very complex one. A lot of the basic fans, the really big fans, were in still very good shape. So there was a small amount of rebuilding the bearings to replace those up to speed. A lot of the original air paths were used, but not all of them, because the system now is a hybrid system with some underseat supply and some overhead supply at the back of the stalls area and at the back of the circle area. So it's a pretty complex sort of hybrid system. The supply system around the stage area has also been changed, and we've now got higher speed nozzles over where the choir seats are at the side. The principal changes that took place were control of the speed of supply through the overhead units at the back of the stalls at the back of the circle. The supply grills and the ductwork there were completely rebuilt. The under-seat supply, of course, is completely new, because in most of the stalls area, the plenum under the seat is now the source of the underseat air, and we had to specify, just a colleague of ours specified the diffusers that are installed under the seats, and they were carefully measured and had to be very carefully tested. The wrong ones were developed, were sent over, and they had to be shipped all the way back and fixed up.
Back to Spain.
Yeah, it was a rather complex system, a complex process, and the measuring process meant that we went in again on several overnighters to eliminate all sorts of electronic noise as well, to track down noisy light fittings, emergency exit signs that make too much noise, and we had to specify very carefully the lighting system for these seats, just to show the audience where the roads end and where the roads.
So you achieved that noise floor figure with the air handling running?
Yes.
You specified that the existing condition was NR22.
Yep.
Was that before or after Peter Rippon got that sailors to clean the fans?
I think that was after. There was one of the systems over the stage, on the S1 or S2, that had blocked filters, I think they decided, so they had to, and the only reason to reach the filters was to climb up from or descend from the ceiling or something to do with it. Sounds like you know quite a lot.
Can I ask a giveaway question? In modelling the sound, I have one particular point in mind, and that's about over the first row of the stalls, about 3.5 metres above stage level.
Right.
Which is where I usually hang my microphone.
Right.
Was there any? You've obviously looked at the audience and the sound behaviour there. Was anything done at where me and the AGC usually hang microphones to look at the performance?
No, yes, we didn't. Simply because we're fully aware that you don't always use the same positions anyway. I know you have preferred positions, and once you get to know a venue, that you can trust the sound in particular locations more.
The previous case, it was the only position which was where soundbar 1 was.
Right, okay.
Now we have great difficulty putting the mic back where soundbar 1 might use the hang.
Because?
We can't get any further out past the screen at the tack zone. We were right on the edge and through a crack. But we were able to do that, and I can actually now provide a before and after recording.
Right. Look, I wasn't made aware of any of those things. Yes, sure. I'd be surprised if you couldn't tweak the position with bits of fishing line from other access points in the ceiling. It's not the ideal solution.
When they get the reelers in, they'll be able to do that. At the moment, we can only deal with a drop and tie off. Okay.
That wasn't
good work, thank you.
It wasn't part of our initial brief.
The engineering up there in the tech zone is impressive.
It is, isn't it? Yeah. It's actually a 3-storey structure for those who haven't been in there.
Your picture of the scaffolding explained how that could be erected.
And a lot of the equipment was actually brought in from a very high level from the rear of the hall.
It's worthy of an article on it. So.
I think it would be, yes. It would be, sure.
I'm just interested to understand how close the final result matched the modelling we did.
In terms of the development, in terms of the distribution of early decay time, very closely. We're very happy with what came about with that. All of the goals, as I think that I've mentioned there, were absolutely genuine goals. That was what we set out to prove or to improve to the client before the process started. And as Judith Isherwood herself said, the CEO of the hall, when we got musicians in the hall, we heard the result, the smile started. And because there was subjectively an immediate response, and of course we had to go back and document that, but we did get very close to the results, yes. The reverberation time was slightly lower than we expected, and that was because the seat's absorption wasn't quite as low as we'd specified in the documentation with the seat manufacturer.
Is there a big change in the audience?
There is a slight change. And strangely enough, one thing we didn't expect was that the orchestra now have the banners in to kill the reverberance in the room as much as possible when they're rehearsing. And I didn't expect that to be the case because the reverberation time is actually slightly less now than before. And we think that's to balance the additional clarity that they hear on the stage.
Is there like a feedback process when you're doing this type of work, so that when you initially design a hall or model a hall and you get to measure the real hall you built, can you feed back parameters into the system so that the next time you go and do that, your results are slightly more accurate?
Our in-house modelling system, absolutely, yes. Yeah, very much so. We test whether or not we're using the right absorption coefficients, whether or not the geometrical simplifications that we've made in the model are sufficient. We've even got to the stage of going to an existing hall, in our case it was the Perth Concert Hall in Western Australia, and producing different types of models with complex surfaces and much simpler surfaces to see the differences that are generated in the computer processes to try and calibrate and increase our understanding of modelling process.
Yeah. Peter and John, you've got a really complex situation. You've got live programs that are 35% classical, the rest are not classical, jazz and intimate groups. You can see that in the pictures there as well. Do you have feedback from the other kinds of groups, not the symphonic groups, as to what differences made with John's sonorization techniques and your acoustic techniques?
Yeah, absolutely we do.
Yes. I think the good thing is there's been really no complaints. It's the odd letter in the age, some disgruntled punter. But, I mean, there's been thousands of people go through it since it opened mid last year, and I think we don't have any nice quotes like Peter does for sound guys don't give quotes. But I think Tina Arena's sound guy said it was like mixing on a big hi-fi system, which was good praise, especially in a hall that still has fairly long reverbs, time about 2 seconds. So it's worked pretty well. I think.
Yeah. From our point of view, the trick was to try and keep the variability in the room acoustic as much as possible. I remember several meetings that I went to with the front centre as clients sitting at the other side of the table, and they said, "Look, you're concentrating too much on the orchestra. You mean you've got to realise that it's actually the orchestra is only in it for 35% of the time." I said, "Yes, I do, but this has still got to be the premier venue for orchestral music in Victoria." And I think that we've achieved a reasonable compromise. We have to be mindful about both situations. Yeah.
On that note, saying you use 35% classical music and the other rest being amplified, it seems a bit weird that in the Tanner process, no real interactive modelling being done. Pretty much, as you said before, pre-field predictions of directivity. But have you undertaken any sort of experience modelling of the actual arrays with room acoustics to the really kind of wall?
The beauty of this is it's a simple answer to that one. When you're designing this sound system, you want to direct the beam towards the most absorptive surfaces in the room. So, which is not the case when you've got a natural source at stage level. And so, to a large degree, not completely by any means, but to a large degree, a very finely tuned sound system will not be affected hugely by the room, especially if you're killing off the reflections from the upper wall surfaces in the room and around the rear of the stage, as is commonly done when we're dressing the stage. So what we were looking for in the variation of the room acoustic was to make the stage area, the stage end of the room, as acoustically dead as possible, using drapes, which we can now more easily deploy from the technical grid, and from the upper wall surfaces, which is where the acoustic bands are suspended.
Most of the proposals really did show the energy. Everyone knows how to do this now, it's not rocket science, so the energy really is concentrated on the audience plane, and that's it. There's no excitation of the space. Well, there is, but it's limited to frequency, sound.
I was there on Saturday night, sitting front row in the dress circle towards the side, and the sound was disappointing. It sounded very thin.
Right.
So I was disappointed in that position from a sound point of view.
Last Saturday, forgive me, I don't.
Cliff Richard concert.
Cliff Richard concert. That would presumably be an amplified concert. Yeah. I don't know who is the sound system operator that night, and I don't know how it was arranged.
Yeah. Hard to know without knowing what the conditions were. Yeah. Look, the mixing guy has a big impact on how it goes. I mean, I've heard some really good sound in there, so yeah, I'll talk to you afterwards. Interested to hear your comment. Yeah.
Just got one slide.
Sorry. Yeah.
I just had a question about the heritage system. You mentioned earlier that you had some trouble with prisms on the sidewalk.
Yes.
If you had no restrictions with heritage listing, what changes did you make?
The answer I'm going to give is slightly obscure, or going about it from a different way, because we don't as a company set out to do the architect's work. We like to work in partnership with the architect on these types of projects. And we like to think that we've got some technical expertise that we can use to guide the architect, but not to restrict them too much to a particular solution. We have some pretty funky solutions. We tried initially to put a wave-like surface around it, which would break up this fixed dimension of it. In fact, that involved, if you like, turning the wall on its side, and pouring a sheet of molten glass over it, but controlling the curvature so that most of the curvature was convex and the concave curvature was very small to avoid focusing on the audience. That would have looked pretty funky, and the architect was quite keen on that type of solution, and that's the type of modelling that the architect was working on initially in the hall. You've seen the new bar, which is down by the waterfront perhaps, with the big yellow conical shaped wall that hides the lift shaft, or all the curved surfaces on the riverfront. That's the type of language the architect was initially thinking of in the interior of this hall. It didn't come to fruition basically because the heritage people came along and said aspects of the truss strop design must be retained, and they had to work out which bits could be retained in order to do some more elaborate and more adventurous work on other areas of the site. So it was a fun negotiation.
Just wonder whether you took the opportunity to crack open a partition or two while you were working on the project.
I did initially in this hall. I haven't subsequently, not yet.
You talked about doing some testing. I just wonder how you do the testing, because the sound of the hall, 2,000 people, and it's got a different sound of the hall. Nobody, so how do you solve it?
We do two sets of testing basically. We do some limited testing with an audience present, and most of the testing we do in the empty hall. And we can use either sets of results to calibrate our computer modelling. Both at the closing concert and at the opening concert, we had swept sine waves played from loudspeakers on stage with the audience in place. We warned them and we asked their indulgence, and it took an extra 10 minutes or so. We told them they were part of the history of the hall, and I think we had everybody's understanding, and that data is very useful because that gives us the occupied room acoustic measurements, the reverberation time in occupied condition. Of course, when the room is unoccupied, we've got much more freedom. We can measure many more seat positions. We can do a more detailed analysis of the response of the room. But you're absolutely right, it does change the room.
So, sorry, as an orchestral player, how does the orchestra practice without people and then play with people? They presume have to change.
Yeah. An orchestra is a living thing, very much, and each musician is highly trained, not just playing their instrument on their own, but in response to the sounds around them. Certainly true. A touring orchestra would come and have a rehearsal in the hall. The MSO rehearse at least on the day of their first of a series of repeated concerts in the hall and in the closest conditions they can get. Because the room response varies enormously when they go to Deakin University in Geelong, or when they go to Robert Blackwood Hall, or they go to Sydney, or when they go to Cologne. Every hall has its own personality. But the basic response, the change in the response between the occupied hall and the unoccupied hall relies on the chemistry within the musicians and the conductor.
Peter, an MSO specific question, since you just brought that topic up. The Iwaki Auditorium was built to be as close as possible to the Melbourne Concert Hall, as it was then, as a rehearsal venue. So now the hall's been remodelled. The Iwaki Auditorium is no longer as similar as it used to be.
A small room will never really sound the same.
Of course, it will never sound the same.
So there is always some difference in terms of energy density, in terms of distribution of reflections.
But is MSO now saying, well, we need to look at redoing the Waikiki Auditorium?
I can't really speak for the longer term plans of the NSO, but I do know that the orchestra is no longer in the direct control of the Australian Broadcasting Corporation as it was, and that the responsibility for their rehearsal venue is now on the side of the orchestra rather than the parent organisation. There may be the possibility of a different venue in a few years' time. But it won't be what wasn't that won't be driven by the differences in Yes, yeah.
Can I also make a couple of other comments? And for those of you who don't know me, I was part of the client team at the concert hall for the first 10 years of its life. I wasn't involved in the design of the facility, but I was involved in the commissioning. And to answer the question about the comments I said about Berenice and Co. Leo Berenice didn't work on the hall. It was the work of Bob Newman, and I worked with him during commissioning phases and also Ted Schultz. Despite the client's response to the finished hall, I know from working with those guys that they were not keen to design as big a room as was being built. That was not their preference, it was the client's insistence. They needed to have that, among other things, seating capacity. And Bob said to me and other people, after the commissioning process was finished, that he would never work on another hall that big again, that he would refuse the contract if it was offered, because he believed that they had exceeded, particularly for that time, and the tools that were available, the design capabilities to do a good job, and he wasn't ever totally happy with it himself. In general, we've all read a lot about the redevelopment and the reasons for it over the last 5 years or so, and both in the technical media and in the general media. I have to say that at times my blood has boiled at reading some of those things, because for whatever reasons of forgetfulness or political aims or whatever, there are statements that have been made that are patently wrong and things have been misrepresented. The hall was designed in an era for a certain set of purposes. The needs have changed over the years, and while it never totally met, and none of us who worked there were totally satisfied with it from day one, while it never totally met the actual needs of the users, there was a design brief which a variety of designers, not just acousticians, tried to work with to build a multi-purpose hall. It was always, from the outset, a multi-purpose hall, and that was its biggest downfall, because they tried to make it do too many things. So, thank you for your indulgence.
Thank you for that. I've learned a lot tonight. Thank you.
So the ABC have had undue influence. It sounds rather like the reported situation with the Sydney Opera House, where the concert hall was the smaller hall and the bigger hall was the Opera House. And the ABC at a late stage said, sorry, the audience size in the concert hall is not big enough, swap. And that's why the acoustic situation is the way it is there, and why the stage mechanisms in the Opera House don't work, because they were designed for much bigger organisations. So we may be grateful for some aspects of the ABC, but at times haven't had always a positive influence on concert hall development.
Well, I don't think the negative effects for the Melbourne Hall were anything like what we've heard about in the Sydney Hall, where the wing space in the Opera House is severely limited because you've got two big halls meet in the middle, and this is where you need to have the cross stages. So there's not much space for that. There are many, many sort of what we now think of as design flaws, but the solution in those days was to build a very deep orchestral pit, stage pit, and to store scenery at different levels vertically. You got a comment about that statement or about the involvement with the ABC?
I don't want to make too many enemies of the ABC. What you said about the organ, though, was absolutely correct. And there were attempts to get the ABC to reconsider so that the organ could be installed at a lower level. And if I may correct you on one thing, the space below the organ was not ever intended to be the control room. That was always up on the left, where John pointed to. They were places to locate cameras behind, so it was just a small opening so that the cameras were discreet. So they had that effect of pushing it up.
Probably my misinterpretation seemed a very big space for one camera.
Well, it was, and cameras were a lot bigger in those days too. And they actually wanted to have, from memory, I think there were actually 2 vertically stacked positions they could have the cameras depending whether the choir lift was up at the back or not.
Right.
So that added, compounded the problem.
Cool. I think I'll wrap up. So on behalf of the Audio Engineering Society and the AAS, a big thank you to John and Peter for their talk. Let's show our appreciation. Thank you all for coming. It's a fantastic turnout we've had. I hope in the future that we can have more combined meetings together. So thanks again for coming.